Okay, so for 9-5 proportions and triangles, we have three ideas here, three concepts that we want to talk about. First of all, triangle parallel proportion, okay? So this might remind you a little bit of the triangle midsegment because these sides are parallel. But notice this is not a midsegment right here because it doesn't cut these two sides at the midpoint. We don't have the dash marks here telling us that, which is why I wanted you guys to make sure when we learned about midsegments that we understood that we needed the dash marks there, okay? So the triangle parallel proportion is just saying if we have numbers here, and I'm just going to draw this out another way, as long as these two sides are parallel, if I know this is 4 and this is 2, and actually I should just use, I'm just going to use letters instead of actual numbers here just to show you guys the concept. So A, B, C, D. What this concept is saying is instead of having to do A is to A plus B, as C is to C plus D, if these lines are parallel, I can just say A over B equals C over D. We can just set up a proportion right off the bat. Now the same thing works here for the parallel proportions. As long as these lines are parallel, and remember the extra arrows tell us that they're parallel, then these lengths right here, I can just do A over B equals C over D, or B over A equals D over C. It doesn't matter how you start as long as you stay consistent. That is so important throughout this whole chapter. When in doubt, set up a proportion, and doesn't matter how you start as long as you stay consistent, okay? One thing to keep in mind is if they give us, let's see, if they say that this whole length is 12 and this part is 4, we should not do 12 is to 4. We should do 12 minus 4 is 8, and then use that part. Don't use the whole when we're talking about parts, okay? And the last one is the angle bisector proportions. Okay, this is just telling us if a triangle has an angle bisector, it makes the parts of the triangle proportional. So if I have, and I'm going to just do this again using A, B, C, and D as side lengths, not as points. But if this length is A, if this length is B, and this length is C, I should call that D, and this one is C, as long as this is an angle bisector in here, notice this is not a right angle. We're not talking 9-4 about like these type of things. Okay, that's not what we're talking about here. We're talking about an angle bisector. That is not a right angle, not the same thing. I can set the proportion A is to B as C is to D. Same as I did on this one, same as I did on the top one. And once again, it doesn't matter how you start as long as you stay consistent. So if I want to, I could say A over C, left over right, equals B over D. Oh, I said that backwards. B over D. I almost didn't say consistent. I almost did left over right, right over left. That would have been bad. I want to stay consistent every time I do this, okay? So that's very important for us to understand. I also could have done B over A, D over C, okay? So there's not just one way to set up the proportion. Doesn't matter how you start as long as you stay consistent. So now let's look at some textbook example problems. Right here, we have an example problem where these lines are parallel. It's not a midsegment, so we're not focused on that. But I could just set up a proportion. And here's the way I like to think about it. If I had a clear, actually let me just grab a pencil. I like just going like this. This over this equals this over this. 12 over x plus 1 equals 9 over x. Now look, they did it a little bit different. They did x plus 1 over 12, x over 9. Doesn't matter that we started different as long as we stayed consistent. And then we could cross multiply. Don't forget the 9 multiplies to the x and to the 1. And then 12 times x, we just solve the equation like normal. I'll erase that in a moment. Same thing with this. We can see that these sides are parallel, and it's asking, what's the distance right here? Side A across the river. Well, since those lines are parallel, I can just say x over 9 equals 8 over 2. That's my proportion. Cross multiply and solve, which is exactly what they did here. They did it a tiny bit different. They did x over 8 and 9 over 7.2. Doesn't matter how you start as long as you remain consistent. And last but certainly not least, please do not mistake this for a right angle. Understand the difference between a right angle, this is not one, and an angle bisector, which this is. When this is an angle bisector, once again, I can just say this over this equals this over this. 10 over 12 equals 18 over x. They did it differently. They did 10 over 18 equals 12 over x. That also works. That's the same as writing it like this. 12 over x equals 10 over 18. Turn the book sideways and we can see that. Remember, it doesn't matter how you start as long as you remain consistent. Okay? So I believe that's all the example problems I have for you, but that's what 9-5 is all about. Remember, for all of Chapter 9, when in doubt, set up a proportion, and doesn't matter how you start as long as you remain consistent.